Hey, good day folks. I'm looking at another problem from HackerRank. This has got a medium level difficulty and they want us to find the highest value palindrome if we are given a large integer in the form of a string of digits and we're allowed to make a certain number of changes to that string. So in terms of our input, we've got the string that represents the large integer. We've got the n, which represents the number of digits in the string. We've got k, that represents the maximum number of changes we're allowed to make. What we need to return is either the highest value palindrome or -1 if we can't make a palindrome. Our constraints, there can be up to 100,000 digits in the string. There can be up to 100,000 changes allowed to the string. The digits in the string will be in the range from 0 to 9. Cool. So they've given us an example, which is if they give us 1, 2, 3, 1, and we're allowed to make 3 changes, they expect us to return 9, 3, 3, 9. So let's look at how they would have gotten there. So the first step would be to make this a palindrome, which is either to replace the 2 with a 3 or the 3 with a 2. So 1, 3, 3, 1 has got the higher value there. So we would pick 1, 3, 3, 1 over 1, 2, 2, 1. So that's got a cost of 1. Okay, now the next step here is to backfill the remaining changes with 9s, and we're going to start with the leftmost digit because that's going to give us the highest number. So in this case we can end up 9339, which has got a cost of 2 because we've changed 2 digits. Cool. So let's look at implementing this. So there's 3 things that we need to do. So we're going to start by filtering out the simple cases. Medium-sized problems tend to have quite strict time constraints on them. So if we can filter out simple cases, we can save some time because we don't have to waste time processing them. Then, like we've done with the example, we're going to convert the string to a palindrome where every change is going to cost 1. And then for the remaining changes, we're going to start backfilling 9s. If we need to change the middle digit, that's going to have a cost of 1. If we've previously changed a digit, and we just need to change that pair to 9s, then we're just going to subtract another 1 because we've already incurred a cost of 1 when we did the initial change. Other costs is going to have, other changes is going to have a cost of 2. Okay, so for the easy cases, we need 2 counters. So we need to know what's the minimum changes required. And we need to know what's how many non-9 digits we've got in the string. Okay, so for this, we do need to loop over the entire string. Okay, so first step here is we're going to count the non-9 digits. So if s of I not equals to a 9, then we want to increase the number of non-9s. Now we've got a problem here. S is not indexable, so we need to, strings are not indexable, so we need to convert this to a vector. Okay. Now for the next step here, we need to make sure that we're not double counting the number of changes. So we only want to count the changes when when I is in the first half of the string. So let's calculate the counterpart to I. So if j is less than I, then we just want to continue. We don't want to double count. Otherwise, if it's not equal to each other, then this is going to have to go into the changes that we've got need. Cool. So now to shortcut return, so if the minimum changes required is greater than the number of changes allowed, then we can just return. And the other one here is if we've got the number of 9s is less than or equal to the number of changes allowed, then we can just return a string of all 9s. Okay, let's just do a quick compile check. Okay, let's do it. Of course, because I need to convert to a string first. Okay. Cool, so it compiles. Now we can move on to the next thing here, which is to convert the string into a palindrome. So we want to have a left and the right index and work our way from the outside in. Okay, now we don't care about the middle digit in this case. We're just going to work on if left is less than right. So at the end of the loop, each iteration, we'll need to shift our indexes. Okay, now what we want to find here is when the two are not equal to each other. So if So in this case, we want to find the maximum digit and assign both to that maximum value. Okay, so we're doing 2 assignments here, but it's got a cost of 1. We just need to make sure that k is mutable. Okay, so thinking here about what we need to do next in terms of backfilling. If we've already changed a pair over here, so we've already paid a cost of 1. So to convert both of them, those to 9s, would actually just occur another cost of 1 because we've already paid 1, so we pay 1 extra, and now we can do that. So we need a set to keep track of which indexes we've already changed. So actually use size. And we only need to keep track of the left most index because that's all the information that we need. Let's just run through this, check that. Okay, cool, no compiler errors. Okay, so now we can start backfilling. So let's reset our indexes. And this time we also want to update the middle digit. So left less than or equal to right. Again, okay. Important here is we want to stop this when we run out of available changes. So k need to stay bigger than larger than 0. Also, if the digit's already 9, then we can continue over this. So left. Okay, so these are the ones we care about. So let's start by the changes that require only a cost of 1. So that's if left equals to right. So we've got the middle digit, or we've already changed that pair. So in this case, we can just say both, okay, left equals to 9, right equals to 9, and the cost minus equals to, we reduce one move. Okay, now else, we look at the operation that's going to cost 2, so we need to make sure that we've got 2 or more moves available. And we don't want to do this on the center, the middle items, so left and right cannot be equal to each other. I forgot the and there. Okay, so in this case, basically the same thing, but this is now a cost of 2. And then the last thing we need to do here is we need to return our results, so convert the vector back to string. Okay, so let's run the code. Okay, I've got some compilation errors. Okay, what did I do wrong here? Actually, let's see which line is it. So 75. Of course. Let's run again. Okay, so we've got one wrong answer. What did I do wrong? Okay, let me pause the video. Okay, I found my mistake. So this just need to be or. Okay, there we go. So submit the code. Cool. Okay, so anything that I did wrong there, it was a typo. I was thinking that if it's either the middle element or if we've already changed it, and then I typed and silly things happen. If you like the video, like it. If you want more, subscribe. See ya.